Hi, I'm Arun, and in this video, I'll talk about our recent paper, Public Data Assisted Mirror Descent for Private Model Training. So the key question we try to address in this work is if we have a large amount of private data and a small amount of public data, how can we best augment the model training process on the private data using the public data? And the baseline that we'll compete against is just pre-train on the public data and then train on the private data afterwards. So sort of the punchline of this talk and this work is that we give an algorithm that demonstrates both theoretical and empirical improvements when incorporating public data beyond just the pre-training. So the algorithm we propose, called PDA-DPMD for short, is to pre-train on the public data and then run mirror descent on the private data using the public loss as the mirror map. And if you don't know what mirror descent and the mirror map are, at a high level, all it's doing is it's taking the noisy gradient on the private data and then reshaping it according to the local geometry of the public loss. So in particular, in directions where the public loss grows very quickly, it'll reshape the noisy gradient to be smaller in those directions, and in directions where the public loss grows slowly, it'll reshape the noisy gradient to be larger. So for our theoretical results, we focus on linear regression, and what we're able to show is that our algorithm is always at least as good as DPSUD with pre-training, but in some non-isotropic settings, it can actually get a better dependence on the dimension than DPSUD. Now, implementing the algorithm is hard, so for our experiments, we focus on a first-order approximation instead, and basically what this first-order approximation does is it just runs gradient descent using a convex combination of the private and public gradients. So we use this first order approximation to conduct some deep learning experiments. In these experiments, we take a random subset of the data and we treat that as public and the rest of it as private. And in all these experiments, we see improvements over just running DPHD or DP federated averaging with pre-training. We also, in some cases, compare it to the state of the art when there is a state of the art that uses public data. And in these cases, we also beat the state of the art. PDA DPMD also has some ease of use benefits. So there's no need to, for example, learn a low rank subspace or anything. It learns its geometry automatically once you choose the public loss. In addition, it can be implemented using only public gradient oracle and no other additional data structures. Thank you for watching, and please feel free to reach out with questions.